Hi everyone, so today I will be presenting different examples on word problems that involves wave properties. So for the first example we have here, a pendulum is observed to complete 20 full cycles in 58 seconds. Determine the period and the frequency of the pendulum. Okay, so I'll write first the given. I have here 20 cycles in 58 seconds. So to solve for the period, it's 1 over f, or 1 over frequency. And to solve for the frequency, that's 1 over t. So in this case, we can first determine your frequency by writing or by dividing 20 cycles by 58 seconds. Now this will give us 0.34 seconds raised to negative 1, or that's 0.34 hertz. Now take note that hertz, or the unit hertz, is equivalent to second negative 1. And since we have our frequency, we can now solve for our period. That's the reciprocal of the frequency. So you can write 1 divided by your 0.34 hertz. This will give us 2.9 seconds. Okay. So now we are able to get for the period and the frequency of the pendulum. So for the second example, we have this problem. A mass is tied to a spring and begins vibrating periodically. The distance between its highest and its lowest position is 58 centimeters. What is the amplitude of the vibrations? So in this case, I will first illustrate to you how we can draw the vibrations. Okay, so we can represent it as a wave. So in this case, let's say this is the wave. Okay. And then the distance from the highest and then the lowest position, this is the distance, is 58 centimeters. Now we are asked to look for the amplitude. Sorry. We are asked to look for the amplitude. So in this problem, our amplitude is just the distance from the highest point to the center or to our equilibrium. Okay? Or it could be from the lowest point to the equilibrium position. So we can say that our amplitude is just half of the given, which is the 58 centimeters. So we'll divide it by 2. So this will give you 29 centimeters. So in this problem, our amplitude for the vibration is 29 centimeters. So this is the answer. Okay, so for our third example, we have here, a wave is introduced into a thin wire held tight at each end. It has an amplitude of 3.8 centimeter, a frequency of 51.2 hertz, and a distance from a crest to the neighboring trowel of 12.8 centimeter. Now determine the period of such a wave. Okay, so what we would like to find out in this problem is the period of the wave. But we are given the amplitude, the frequency, and a distance from a crest to the neighboring shore. Now take note that the formula for the period, our period is equivalent to 1 over f, okay, or the reciprocal of our frequency. Now in this problem, we have a lot of given variables or given values. We have the amplitude, the frequency, and a distance. But to solve this problem, we can use directly your frequency, which is the 51.2 hertz. Okay, I mean, we can solve this problem just by using the variable or the value for the frequency. Okay. So to solve for the period, we'll divide 1 by 51.2 hertz. So this will give us 0.0202. That is in seconds. So the unit for the period in this case is seconds. Now take note that hertz is equivalent to seconds raised to -1. So our period will have the unit of seconds. Okay, now you can observe that this problem has a lot of given values or given variables, but we only need the frequency to solve this problem. So you will sometimes encounter word problems in physics or even in math, okay, that there are a lot of givens in the problem or given values in the problem, but we only need some of them or even one of them. So it doesn't mean that all the values that is given from the problem or all the values that are given the problem are needed or have to be used in solving the problem. Okay, so we'll proceed to the next example. So for the fourth example, we have here, Frida the fly flaps its wings back and forth 121 times each second. The period of the wing flapping is blank seconds. So we are going to determine for the period again. So the given in the problem is 121 times each second. This is actually the frequency from the word itself, that's 121 per second. So you can actually write this as 121 seconds raised to -1, or this is 121 hertz. So this is just your frequency. And we can directly solve for our period, that is 1 over f. So 1 divided by 121 hertz. This will give us 0.0083 seconds. So this is now the period of the wing flapping of Frida the fly. So that is now the answer. Okay, so for the last example, we have here sound waves are longitudinal waves in air. The speed of sound depends on temperature. Now at 20 degrees Celsius, it is 344 meters per second. What is the wavelength of a sound wave in air at 20 degrees Celsius if the frequency is 262 hertz? Now what is asked in the problem is a wavelength. Okay. Now take note that our formula for the wavelength is equivalent to speed over our frequency. And then the given here, we have speed, that's 344 meter per second, and the frequency is 262 hertz. Okay, now we can disregard the temperature since we are asked for the wavelength at the same temperature. So that's 20 degrees Celsius. We're given of the speed of sound at 20 degrees Celsius, and we are asked for the wavelength at 20 degrees Celsius. So it is not useful in solving this problem, okay? Or we cannot utilize using our temperature. Now we can directly solve for this problem. We have here 344 meters per second divided by 262 hertz. Or we can use the other unit for hertz, which is the second raised to -1. So seconds here will cancel out, and then we will be left with meters. So calculating 344 divided by 262 will give us, sorry, that's not 0, 1.31 meters. So this is now our final answer. Now the SI unit for the wavelength is in meters. And then also, since our given speed is also in meters, we will be left with the unit meters. So that is why our final answer now is 1.31 meters. Okay, so that's all for today, or that's all for this video. If you have questions, clarifications, and suggestions, please feel free to send me a message through my Facebook Messenger. Thank you and God bless.